Algebra 1, 8.5b, we're going to do motion problems and solve for rate. And we said in the last video, when we were solving for distance, that when we're solving word problems, we need to understand what the problem is asking of us. We need to develop and carry out a plan and figure out how we're going to solve it. We need to find the answer and check to make sure we did it correctly. So you got to check it, okay? And the strategies that we can use for word problems are these: drawing a diagram, finding a pattern, making a table, writing an equation. We can guess and check. We can even work backwards, solve a simple problem, a simpler version of it. We can use a formula. And in this video, we're going to make a table, write an equation, and use a formula, okay? So we can use multiple strategies for one problem, all right? So here's our rate problem. We're using distance equals rate times time. And this is the formula for distance, rate, and time. And when we're solving for the distance traveled, it's the rate of speed times the time. Well, now we're going to be solving for rate. So we need to solve for r. And we solve for r by doing the distance divided by the time, because we take the original equation, d equals rt, and we divide both sides by the t. And that's going to get rid of this t and isolate the r, and we're going to have r is equal to d over t. See? In our next video, we're going to solve for time, all right? Now, distance can be miles, kilometers, yards, feet, etc., and we talked about this in the last video. And this is what's interesting about the rate. The rate is how fast you're going, the speed, like miles per hour, kilometers per hour. And the formula for rate to solve for it would be r equals the d over the t, like we just talked about right here, right? Now, if you look at this formula, we're taking the word per from our rate words, and that's actually the fraction line. So the rate is equal to the distance divided by the time. The rate is equal to the miles per hour, or feet per hour, or kilometers per hour. And this word per is almost like it's taking the place of that fraction bar. See that? And then, of course, time can be in any increments of time, like months, years, days, weeks, hours, minutes, okay? So it took 3 hours for a motorboat. So this is a boat that has a motor on it that's running, okay? It took 3 hours for a motorboat to travel downstream with a current of 6 miles per hour. The return trip against the current with the motor running took 5 hours. Now we need to find the speed of the motorboat in still water with no current working for it or against it. So if the water was still and this motorboat's motor was running, how fast was the boat going? We need to find the speed of the boat without the current. So we're going to let r equal that rate of speed in still water without the current. We're going to let r plus 6, that's the rate of the speed with the current going downstream, because the 6 mile per hour current is helping it, isn't it? We're going to use r minus 6 as the rate of speed against the current traveling upstream, because this current is going, if this is the river, and the current is going 6 miles per hour, but the boat is trying to go against the current, it's going to be fighting that current, isn't it? So we're going to do r minus 6. So now we can make a table. We do our distance is equal to rate times the time, and the downstream is going to be distance equals the rate plus 6 miles per hour current, and it took it 3 hours. And going upstream is going to be d equals the rate of speed minus that 6 hours, because it's fighting it, and it took 5 hours. Now we have a system of equations from each row from this table. We have d equals r plus 6 times 3, and d equals r minus 6 times 5. See? So we can use the substitution method to solve this system of equations. So here's our two equations, and because it says that d is equal to r plus 6 times 3, we can actually use this part of this equation in place of d in that equation. See that? So now, instead of d equals r minus 6 times 5, we have r plus 6 times 3 equals r minus 6 times 5. See that? So we took this part and put it down here. So now we have to do our distributive property, don't we? We have to do 3 times r and 3 times 6. And then we have to do 5 times r and 5 times 6. And we have to pay attention to the plus sign and the minus sign. So now we have 3r plus 18 for this side, and we have 5r minus 30 for this side. And we need to isolate the r to solve for the rate, don't we? So we can take away 18 from both sides and create a 0 pair here. And we take it away from this side and get a negative 48. So now we have 3r equals 5r minus 48. So now we need to still isolate for the r. So let's take away the 5r from this side and from this side, and that'll create a 0 pair here, and that'll make only r on that side. So 3 minus 5 is a negative 2r, and that equals negative 48. Now we can divide each side of this equal sign by this coefficient negative 2, and a negative gives us a positive r when we divide, and a negative 48 divided by a negative 2 gives us a positive 24. So we know the rate of speed is 24 miles per hour, because that's r. It's the rate of speed in still water, and that's what we were trying to solve for, wasn't it? Without the current in still water. So we know our answer is 24. Okay? With no current. That's the miles per hour that the motorboat was going. And we can check it by plugging it into both equations to see if it fits, to see if it makes them true. And if the distance is equal to the 24 plus 6, that's 30 times 3, right? That's 90. And if it's equal to the r as a 24 minus 6, 24 minus 6 is 18 times 5, and that's 90. Yep, it made both equations true. So it fits, so it worked. So our next video is going to be 8.5c, systems of equations still, word problem, motion, and we're going to solve for time. And if you want to know whether to use the substitution method or the addition method in a word problem, there'll be a link for that video. If you want to see how we solved for distance in the previous video, there'll be a link there, or how to clear fractions from any equations. That'll be, and pardon the shadow, that'll be in this video's description, okay? And I'm also putting a link to my intro algebra word problem videos 8b and 8c that tell you how to rearrange formulas like we did over here so that you're solving for the variable that you really want to solve for, okay? So I hope this was a good explanation, and I'll see you in the next video, and we'll talk about solving for time. Bye.